Okay, thank you for reminding me that, to record the class. Okay, here I have the first example. It says the current in a light bulb is 0.835 amperes. How long does it take for a total charge of 1.67 coulombs to pass through the filament of the bulb? Okay, so this is a very simple example, but I just want to remind you, current is going to be measured in amperes. Denoted by the letter A, and 1 ampere is equal to 1 coulomb over second. So in case that sometimes you need to cancel units, this is what it represents. Okay, so in this sample problem, very simple, it says we're talking about a light bulb. I'm going to highlight our givens. I'm talking about the current in the light bulb to be 0.835 amperes, and then it says how long does it take for a total charge of. They're giving me the charge, and they're asking me how long does it take. They're asking me to find time. Okay, so my givens, I have the current. Current is denoted with the letter I, uppercase I, okay, is 0.835 amperes. I need to find the charge. I need to find the time. Delta T is unknown, and they're giving me the charge for this, which is 1.67 coulombs. Okay, the main equation for current is this one. Okay, we have the main equation for current, that is current is equal to the charge divided by time. Okay, this is the main equation. Since we're looking for the time, we're going to look for the isolation for it. The isolation will be delta T equals delta Q divided by the current. And then all we do is we substitute the charge given in amperes, coulombs, and the current given is in amperes. It is 0.835 amperes. Now, take a look to this. I have coulombs, and I have amperes. I cannot eliminate units like this. But as a reminder, what does 1 ampere mean? 1 ampere, as I told you above, is equal to 1 coulomb per second. So, if we have amperes, it is the same as we have coulombs per second. Okay? So in this way, you are able to cancel coulombs with coulombs, and the remaining unit will be seconds. So delta T, how much is this?
2.
2. Okay? So it takes 2 seconds for that total charge to pass through the filament. Okay? It takes only 2 seconds to do that. And for that, that's it. You can see this kind of exercises are very simple. It doesn't have anything complicated in it. All you have to do is plugging in the givens. But if you have a doubt on this exercise, you can ask me. I'm going to work in the second example. I'm going to do one more example before this one because this one is kind of the longest. So I'm going to work with this one. Example 2. Well, we're talking about an electric train in the year 2000 that runs between New York and Boston. It takes a travel time of 3 hours. The train is not super fast, but it is comfortable, very safe, and environmentally friendly. Find the charge passing through the engine during the trip if the feeding current is 1.8 times 10 to the second power. The first part of the problem is just context, okay? A train between New York and Boston, but that doesn't help us to solve the problem. But they're giving me the total travel time, 3 hours, okay? Then more characteristics that are not useful for the problem, but I think the problem is telling me that I need to find the charge passing through the engine during the trip, okay? This is telling me the duration, okay? And then they're giving me the current to be 1.8 times 10 to the second power. So what do I need to do? Of course, I already highlight the givens. I'm just going to write them as part of my information. I have the total travel time, delta t, is 3 hours. But you know that we cannot leave this unit in hours because ampere has coulombs per second, so I need my time to be in seconds. So I'm going to do the conversion in the first place. What is the conversion between hours and seconds? What is the conversion between hours and seconds? Did you forget already?
Going from hours to minutes and then from minutes to seconds. That's more easy.
Exactly. If you don't remember the conversion factor, the direct conversion factor, you can do it in 2 steps. Like in 1 hour, you have 60 minutes. Just remember that it must be in the opposite sides, and also that in 1 minute you have 60 seconds. You can do it like this. You don't really need to know that. Or you can use the direct conversion factor, that is that in 1 hour you have 3,600 seconds. Okay, that's the other conversion factor, but you can do it in 2 steps too. Okay, both ways are going to give you good answers. How many seconds are this? Well, I got 10,800 seconds. Did you get the same as me?
Yes, yes.
Yes.
Okay. So it says find the charge. So I'm going to look for the charge. And they're giving me the current, okay? The feeding current is 1.8 times 10 to the second power. So current is equal to 1.8 times 10 to the second power. These are amperes. So I need to find Q. So you know the main equation? The main equation is equal current equals delta Q over delta T. If you want to know what current is, so you just isolate for Q. So you say delta Q is equal to current times delta T. The current that we have in the problem is 1.8 times 10 to the second power amperes. Remember what an ampere means? Multiplying times the time, which it gave us 10,800 seconds. As a reminder, 1 ampere is 1 coulomb per second. This allows you to cancel seconds, and in the end, you have delta Q equals to how much? Well, I got 1,944,000 coulombs. This is what I got. If you write it in scientific notation, it will be 1.94 times 10 to the 6th power. Both answers are correct. In this case, I prefer this one because it is an exact answer. I don't have decimals in it, so I prefer the first answer for accuracy purposes only. But both answers are good. Wait. And that's it. I mean, it's not too complex at all. It's not too complex at all. The equation is very simple. Please take advantage of this topic. It's very easy. How many times have I introduced you a topic this easy? Just a few times. Well, not several times to be honest. But this one, under my experience, this one, it is absolutely necessary that you get a 10 out of 10 if possible. If you want to get a good score in the end. It's a good way to get it. So please do it. Now, we have one more example. This one is a little bit more complex, but it doesn't mean that it's difficult. But it says, take a look. We're talking about a light bulb, which is 100 watts, that has 100 watts of power. Light bulb draws 0.83 amperes of current. Then it says, how long does it take for 1.9 times 10 to the 22nd power electrons to pass a given cross-sectional area of the filament? We're talking about a light bulb, okay? So this is what we have, okay? And what it means in the end is, what is current? Okay, what is current? The current in a system is going to be, it's going to depend on the amount of electrons. The electrons are those that are responsible to, to drive current from one side to another because they carry current, okay? They are the responsible to carry the charges that in the end will produce current. So in a light bulb, okay, in a light bulb, okay, you know that you just put a light bulb, uh, you turn it on by just pressing the switch, okay, and it is on. And when it is on, it's because this filament is shining, okay, and that is what allows us to see the light or the brightness of the light bulb. But in the end, those are just electrons, but millions of electrons that are passing through the filament, and that they do it very fast, in fractions of seconds, okay, so they are very fast. So when the problem says that I want to know how many electrons, no, that I want to know how much time those 1.9 times 10 to the 22nd electrons will pass through the area. That means that given an amount of time, I'm going to put a stopwatch just to count the electrons. And when I have this amount of electrons, I will stop to count. Okay? I will stop the stopwatch. Okay? And in the end, I will see. It takes 2 seconds. Or no, it will take just 1 second. But that will depend, okay, on the amount of current that you will need. So in this case, the light bulb needs, sorry, I didn't have to erase it, but I did because I did a mess. Bueno, así lo voy a dejar. Okay, so in the end, what do I have? Amperes, I have electrons, and they're asking me how long does it take? I'm talking about time. Now, this information from here, the power of the light bulb, doesn't help me at all for this problem. Because what do I need to get the time? For time, I need charge and current. I have the current. I don't have the charge. But I do have the number of electrons. If I have the number of electrons, the amount of electrons, okay, I can tell that I can get the charge, okay? So this is an exercise that is done in like 2 steps. It's a little bit more complex, but in the end, it's also very easy to do. So let me show you. So these are the givens. Okay. The power, I don't need it. I can write it as part of the given, but that's just additional information. I don't really need it. But if you want to write it, you can write it and still you can't use it. Okay. So you can write that the power is 100 watts. We know that the light bulb has or draws a current of 0.83 amperes. And it's asking me about the time, which is what I'm going to look for, and it's giving me number of electrons. It's not giving me charge, it's giving me number of electrons. So it says 1.9 times 10 to the 22nd power electrons. So that's all the problem is giving me. So in this case, electrons are electrically charged. So if you know the number of electrons, you can get the charge that all of them combined have. And if you know the charge, then we can get that time. Okay, so basically this is like the map that we're going to be doing from number of electrons to charge and from charge to the time. So in my first step, I'm going to calculate the total time that all those electrons have. Okay, so this is going to be my first step. From number of electrons. Okay, so the electrons that are given are 1.9 times 10 to the 22nd power electrons. And there is an information that I gave you at the beginning, is this one. Okay, the one electron has this amount of charge. And here the value is negative, as you can see. But here I put these bars. Do you remember what these bars mean? That we're going to use what value? Guys, what does this bar mean? In math, absolute value. Okay? Yes, absolute value. So that means that we're going to take just the value, the number, 1.6 times 10 to the negative 19 coulombs. Okay? Just remember this. One electron has 1.6 times 10 to the negative 19 coulombs of charge. That is one electron. Okay? That's the charge of just one electron. But we have this amount of electrons, so I need to get the total charge for all of them. So what I need to do is just a conversion. Okay, it's just a conversion. So what I do is my total charge is going to be 2. My number of electrons multiplying the individual charge of each electron. This is, if you want to keep it as a formula, it's going to be like that. So Q total is equal to my total number of electrons times the charge. Each electron has a charge of 1.6 times 10 to the negative 19 coulombs. Okay? Or you can leave it like a conversion factor. You can say times, okay, one electron has a charge of 1.6 times 10 to the negative 19 coulombs. In the end, the number of electrons and number of electrons will be cancelled. What is the total charge? what is the total charge?
Miss, I got 3040.
3040. These are coulombs, okay? So this is the total charge for all these electrons. But this is not what we are looking for. We are looking for the time, okay? We are looking for the time. So we say in the second step, we're going to get from Q, we're going to get delta T, okay? The equation for delta T, I already isolated, is this one. So I'm just going to copy this. This kind of thing. And then I just plug in the givens. Delta T is equal to the Q, which is 3040 coulombs, divided by the current. The current, okay, is 0.83 amperes. Remember, what is an ampere? Ampere is 1 coulomb over second. So coulombs and coulombs will be cancelled and the remaining unit will be seconds. How much is this? How much is this?
3,662.65.
Okay, so this is the time. 3,663 seconds. Okay, that's good. This time is good. But guys, when you have this amount of seconds and you are like having a random conversation to someone, okay, we usually don't say it takes 3,663 seconds. We usually tend to round things. Nosotros redondeamos cuando hablamos así, ¿verdad? No, de aquí a San Pedro como 10 kilómetros. That's what we say. We round everything because it's simpler. Now, tell me, in what better way can we express this amount of seconds? En unidades de tiempo. ¿A qué estamos más acostumbrados? ¿Hablar de horas, minutos o qué? Uh-huh. Don't get me wrong, this answer is good, okay? This answer is good. But I'm just telling you that sometimes it's necessary that we use, in our daily talk, that we use the more frequently used units. In the case of time, we can refer about time in hours. If you convert this to hours, it's going to give you around 1 hour. So you can say that it takes 1 hour, okay, 1 hour for those electrons, okay, to pass through the filament and draw that amount